This is Matthew Cutler-Welsh with Passive House Accelerator, and thanks for tuning in to this special bonus episode of the Passive House podcast, recorded live at PhiusCon 23 here in Houston, Texas. And a big thanks to Zola Windows for their support for this series. I'm here with Kimberly Llewelln from Mitsubishi. Kimberly, how are you enjoying the conference so far?
I think it's fantastic. This is one of my two favorite events of the year. I feel like it is the most vibrant building science community who are pushing the envelope on so many fronts, from actually developing and building projects to working on codes and regulations to figuring out the finance piece. So it's great to be here.
And you're from up the road, along the road?
Over the road, yeah. Almost due west from Austin, Texas.
Right, so similar climate, similar type of environment?
Yeah, very, very similar. So we get slightly more extreme dry bulb conditions, so hotter and colder, and slightly less humid, but not much. So very, very similar.
So yesterday we were in a session talking about sort of Phius and the opportunities for Phius beyond the US. What were your takeaways from that?
I think what I really loved hearing was, first of all, that there's already a common vision that I think is coagulating.
Yeah.
And that is that we understand our principles very well. We understand the principle of the building physics very well. One formula and one size does not fit all, which is already baked into the Phius program. And we need to probably be even a little, not probably even a little, we need to be more intentional around allowing for adaptability and then diversification that's built from those core principles as we try to expand into a more global market.
Yeah. So going back to your technical ability, which is significant, what's your background from a technical perspective?
Well, I trained as an engineer in graduate school. I studied environmental engineering in a thermodynamics lab. And so my fundamentals were strong in thermo, and that helped me, like, when I transitioned into the construction industry, which happened just by one of those funny, flukes of life. I met Christoph Irwin is here, owner of Positive Energy. I met Christoph Irwin through a mutual friend, and they were doing high efficiency building and also energy ratings at the time. And he asked me if I wanted to sign on as an energy rater, and I didn't know the first thing about energy rating, but they put me through the training, and I ended up doing that in full-blown mechanical design and building failures related to moisture issues in our climate for about 6 years with them. That's where Mitsubishi found me.
Right. I'm assuming that everyone in Austin knows Christoph. Even I know Christoph.
I think it's a fairly safe assumption, yeah.
Certainly in this industry. Are there similarities from doing flow dynamics to doing more moisture-related building science or hydrothermal analysis? Are there some similarities there, or are they completely different?
Well, what I was working on was really pretty different. But again, everything we did was dealing with chemical engineering and the second law of thermodynamics. So when you go to any fundamentals of building science, a lot of times the first slide you'll see is some form of the second law of thermodynamics, and making sure that you're always looking through the lens of more goes to less, whether you're talking about a concentration of energy, of moisture, or pressure.
Yeah. So, big learning from me on the first day, even before the conference got started on the tour, was the need for dehumidification separately from heating and cooling, which is again separate from ventilation. So I understand the separation of ventilation from heating and cooling. But tell me a bit about the need for dedicated dehumidification systems, particularly in this climate, which is warm, and to me it certainly feels pretty humid.
Yeah. So it's all about the ventilation latent loads, and that's where it really becomes impossible in this climate where you've got projects where you're required to have continuous ventilation. Meaning outside.
Where is that requirement coming? Is that a physical requirement or is it a code requirement?
Oh, well, it's a passive house requirement. So since we're here, I was speaking to that. But ventilation is also a code requirement, just a general building code requirement in the state of Texas. Now, you can do that in different ways. A lot of people think that it's safer to, do like exhaust ventilation, but the bottom line is it's coming in somehow and somewhere, and you just don't know where. So you're bringing that humidity into your building somehow. So the load is there regardless of what method or strategy you use, whether it's balanced supply or exhaust only. When you control it, you at least have the chance of addressing those ventilation latent loads at the source.
Yeah.
So why is it important? Let me give you an example. So if you had a new construction house that was 2,000 square feet, 3 bedrooms, you'd be required by code to, depending upon which code, it'd be something in the range of 80 CFMs. So we're not going to split hairs there. We'll just say 80 CFMs. So if you ventilated continuously, so bringing 80 CFMs continuously into a house in this climate, you would be introducing something like 5 gallons of water, 80 pints per day, of just with your ventilation load. So that's not including any of your internal gains from cooking or showering. That's not completely captured by your exhaust system. So that, especially in higher performance construction, like that is significant additional load.
And if you've got a lot of people talking about ERVs here as opposed to HRVs, that's not going to help you in that situation.
Well, so it helps, but the best efficiencies you're going to see at your peak humidity load conditions are about 40%. That's the best you're likely to see for latent.
30%?
30 to 40%. Latent.
Right.
So that's different than sensible. You can get much better recovery efficiencies, 70, 80% for the sensible. But the latent is different. Latent is the same thing as humidity. I should have said that. Okay. Yeah. So if you got 40% at that, 5 gallons a day, okay, so you've reduced it by 40%, but you've still got a very significant humidity load that you're introducing, even with an ERV. So that is probably, I'm sure it's been addressed over and over again. Even the Zender gentleman from Zender, who was talking about his high efficiency ERVs, saying in this climate, you can't rely upon the ERV alone. You need supplemental dehumidification.
Yeah. I guess the other thing that I hadn't really thought through is the timing and the fact that you, when it's warmer and it's more humid, you need fresh air, but you don't necessarily have the cooling on, so you're not getting dehumidification through cooling in that sort of shoulder season, and that's where you might need dehumidification.
Yeah, that's exactly it. So your cooling system is designed to come on when it sees what we call a sensible load. So when it's hot outside or when it's hot inside because of your gains. But if there's no significant sensible load, but you've got your humidity load, then your system's not designed, your cooling system isn't actually designed to handle that. And so your shoulder seasons where you see those often your peak humidity loads and you've got no no system that's actually designed to handle that humidity load.
Yeah.
Your cooling system isn't running. So dehumidification happens as a byproduct of cooling, but if you don't need the cooling, it's not happening.
Yeah. And even if it is running, it might not be
enough
adequate in this environment, of which there are many. That's one of the reasons why I was excited to be here, is because we have warm, humid climates in Australasia, and we have a lot of humidity. I mean, we have really high humidity, and that's one of our biggest problems, is not recovering heat. Yeah. It's getting enough cool and fresh air, and then getting rid of moisture. So it's a big problem outside of here. What's Mitsubishi doing specifically for helping to solve this?
So Mitsubishi, we've done some good work improving what we call our dry modes, which functions more like the ERV does in a way, where we can take the edge off the humidity load. So it's doing now the systems are doing what you would expect them to do, with a low coil temperature and a slower fan speed. We've improved our controls offering so that you can base the running of that dry mode off of a humidity sensor instead of just somebody having to turn it on manually.
Right. Mm-hmm. Right. So actually sensing the indoor conditions and having more automation.
Yes, exactly.
Right. And what about in terms of the unit? Is there much change in the actual units themselves?
Well, we're working towards more appropriate heat exchanger sizing. So, all manufacturers, they have, they'll use the same size heat exchanger for a few different capacities, and then the program is different. Like for the programming is different for different capacity systems. But for, if you have the same size heat exchanger for a smaller capacity system, you're going to get less humidity control out of that, because essentially you've got more surface area that you're delivering cooling from. What it means is that, I'm not explaining this very clearly, what it means is that the coil temperatures are not going to be maintained as cold, which means they're not going to have as much latent capacity. Yeah,
I mean, one of the things that struck me from going to see Jesse's house and the tours was how tiny the ERV was relative to the rest of the air handling unit, which was the biggest part was the heater, cooler, air conditioner, and then also the dehumidifier box sitting on top of the air conditioning unit. And those ducts are big. They're at least 2 or 3 times the size of the ventilation units. And I think that I hadn't fully appreciated the amount of air, the volume that you need to move to get rid of that moisture and to pull it out. And that's a closed system, because it's not coming inside or outside of the house. It's working within the thermal envelope, because the ERV is doing the heavy lifting in terms of bringing fresh air in. But then there's a separate system that's running internally to get the humidity down.
So I haven't laid eyes on that design specifically, but one reason they might have larger ducts is to control the static pressure of that air distribution system to match the fan, the air handling unit fan.
Because you don't want big drafts inside?
Because you don't want to have more resistance within the duct system than what this fan is designed to handle. Right.
All of this also leads me to the question about capability in the industry. And something I've become aware of where I work is that there are lots of really clever, experienced mechanical services engineers in the commercial space. In bigger buildings, but very few in the residential space. And there are ventilation salespeople, and heat pump salespeople. But do we have a problem with capability and the number of people qualified in this residential space in the smaller systems.
Yes, absolutely. I mean, we just generally have a trade problem with qualified trades,
Right.
And I've seen some optimistic movement towards young people going into trades programs. So I'm hoping that trend really is growing some roots. But the short answer is yes. It's hard to find qualified contractors, especially to do this kind of higher performance installation work.
Yeah, because it gets quite complicated. It's not simply a matter of installing ductwork and fitting a box up in the ceiling somewhere.
I feel like that's our fault, though. I feel like we really need to improve our playbooks, because I don't think it needs to be super complicated. I mean, what are we trying to do? Like for passive homes, it's usually, unless they're just a handful of bedrooms, you're usually going to want to install a ducted system. So you've got a ducted air conditioning system, space conditioning system. You've got ERV, and it probably its own duct system, and then you've got a dehumidifier. It's not that hard to integrate the dehumidifier and the space conditioning system. I think the real question is, what do we really want to do with that ventilation air?
Right.
And that's where it gets a little bit trickier.
Yeah. I mean, another issue that came up during the tour was finding people who are willing to commission the system properly. So installing is one that we're designing, then installing, but then also checking that it's up and running and working properly, and probably coming back again at the change of seasons to make sure it's still working.
Set up properly, operating as intended. Yeah, that's true. I feel like there's so much opportunity business-wise for people. For people who are technically inclined, for people who like field work. I want to see. I'm hoping that we're going to see more people entering into the space. You know, what happened back in I guess it was the mid 2000s, with ARA funding, there was this big growth in the rater community. Everybody thought that there was going to be like tons of rater work, and there was some, but it was never as much as anybody thought. I think that and we've built upon that rater community, you know, for weatherization programs. We've pulled from the rater community for commissioners and raters for passive house community. Utilities use the same community to verify their savings from their rebate programs and weatherization programs. So I'm hoping to see, like with the IRA, with the Inflation Reduction Act, I'm hoping that is going to spur a growth in these expertise, particularly around HVAC and commissioning, like you're saying. I think it's a rater community, again, I guess that's the tie-in, that it's a rater community that probably is best positioned to reach into that space.
Yeah, I think so too, because it's far better to have someone come in who's got a level of independence rather than the person who sold you the kit to come in and do it, even if it's just to verify it. What are there any other things that you'd like to see? You know, what would you like to see happen either as a result of this conference, Phius passive house wise, or ventilation and heating cooling specifically? Where would you like to see things in the next, say, 3 years?
Oh gosh, there's so many things I want to see happen. That's why I'm always so busy. I would really like to see our industry work on a latent efficiency rating for mechanical systems. So one thing that's really skewed HVAC performance, heat pump performance, has to do with our existing SEER and EAR ratings, which don't take latent capacity and latent efficiency into account.
Yeah.
And so as we're seeing just across the board, lower load new construction, which is lower sensible load new construction, and we're seeing more and more ventilation being required, I think it's going to come to a head where we see, like, you know, the space conditioning systems really could do a lot more of the heavy lift of the latent control at higher efficiencies if we just didn't skew all of the ratings towards sensible efficiency. So we're actually working against ourselves. So in order to qualify for many rebates, especially in the South, you have to meet these EAR and SEER criteria, but that says nothing about the latent efficiency of those same systems. So you have people basically misapplying equipment and installing really high sensible efficiency systems when what they really need is a system that gets credit in its efficiency rating for having good latent efficiency.
And that's going to be more important the further south you go, because the more humidity.
And it's going to also start, we've already seen it stretch up into more northern climes where the lower the sensible load, especially with passive buildings, like they're starting to see humidity issues also.
Right. So
they have no sensible load.
Yeah. Very good.
Mm-hmm.
Well, thank you.
Thank you,
I hope
Matthew.
you enjoy the rest of the conference.
Thanks.